Okay, now let's talk about something called stereoisomers. Stereoisomers is like an isomer. So we've talked about isomers. We've talked about constitutional isomers. All right. Try to think in your head. Okay, constitutional. What was that? That was same formula but a different structure, like CH3, CH2OH versus CH3O, CH3. That's a constitutional isomer. Stereoisomers is where the molecules are identical with where the atoms are placed, but they differ in three-dimensional space due to something called restricted rotation. Okay. Now, in this case, we are going to see stereoisomers in a different chapter, but we're going to see a different type of stereoisomer. In this case, double bonds, you cannot freely rotate around a double bond. Okay. So this 2-butene, all right, this 2-butene can be drawn in two different structures. Okay. Here's one structure. Okay, so you notice I have a carbon-carbon double bond. Okay, and I have 4 groups. Remember, it's trigonal planar. Notice one of the carbons has a hydrogen on it, and the other carbon has a methyl group. Well, where do I put the hydrogen and where do I put the methyl? I don't know. Let me just arbitrarily put a hydrogen there and a methyl there. All right, well, the other carbon has the same exact thing. It has a hydrogen on one side and a methyl on the other. So where do I put the hydrogen and where do I put the methyl? I don't know. Let me just arbitrarily put a hydrogen there and put a methyl there. All right. Now, I could have switched them. I could have flip-flopped them. I could have put them anywhere I wanted, but this is one of them. I could have put the CH3 up here and the hydrogen down here, and that would give me a different molecule, or put the CH3 up here and the hydrogen down here. Okay, so that's what is being shown down here. That's what meant by stereoisomer. These atoms are connected in the same arrangement, except they differ in 3 dimensions. One of them have the methyls on the same side of each other on this. Remember, there is no free rotation around that double bond. I cannot freely rotate. This one, I have the methyls on opposite sides. These are 2 different molecules. They are called stereoisomers. They're not constitutional. Okay, why are they not constitutional? Because the atoms are hooked in the same arrangements. This is a 4-carbon chain, 1, 2, 3, 4, with a double bond at the 2 carbon. This is also 1, 2, 3, 4, with a double bond at the 2 carbon. They are both called 2-butene. They are both 2-butene. They're both the same molecule, but yet they're not the same molecule. Okay, because they differ in 3 dimensions. This one is called the cis molecule. So we always have to have different names for them. This is the cis. Cis means the same side. Same side. Kind of that's how people say it. Cis, same side. Cis, same side. All right. Trans means the opposite sides. Okay. So this would be called cis 2-butene, and this would be called trans 2-butene. All right. Here are the names right here. Cis 2-butene versus trans 2-butene. Okay? So, and this happens on double bonds all the time. All right? So, whenever 2 groups on each of the carbons are different, you have a possibility of 2 isomers. Okay? These 2 groups must be different from each other. Yeah, like if I have a methyl and a methyl, then I won't have a different isomer. These have to be different. I can have an ethyl and a methyl and a chloro and a methyl. Okay, and those 2 also must be different. Okay, so like for example, these are identical. If I were to switch these, let's say I took this hydrogen and put it up here, and took this hydrogen and put it down there. It's the same molecule. Those are not stereoisomers. Okay, so here they actually kind of show you how they flip-flop. So there's no cis or trans isomers. All right, you have to have 2 different. All right, and here's kind of I like this slide because it shows you the difference between constitutional isomers and stereoisomers. Constitutional, same formula, okay, so the formula for all of them is C4H, let me see, 3, 5, 6, 7, 8, okay? Notice my double bond here is at the 1 carbon, so this is called 1-butene. These are called 2-butenes, all right? Just by looking at the names, if the names are different, they're different molecules. So those are constitutional isomers. So this is a constitutional isomer to the cis, and it's a constitutional isomer to trans. I don't know if you can read this down here. Let me see if I can lower this a little bit just so that you can see what it says. There we go. You see how it says constitutional isomers down there? Okay, so This is a constitutional isomer to both of these, but these are stereoisomers. One is the cis, where they are on the same side, and the other one is the trans, but they're both 2-butenes. Okay? This part talks about saturated and unsaturated fatty acids. This is where the cis and trans, you guys heard of trans fats? Of course you've heard of trans fats. Who hasn't? Okay, I think even my 5-year-old has even heard of it. Okay, so what a fatty acid is. So you guys learned what an acid, a carboxylic acid group. A fatty acid is where you have a carboxylic acid group. The structure's here? No, let's kind of draw this. You have a carboxylic acid group, and you have 12 to 20 carbons. I'm not going to put all of them, but imagine 12 to 20 carbons all the way down here. That's a fatty acid. Why is it fatty? Well, you have this very nonpolar tail, which fat is very nonpolar. It's oil. It's basically a hydrocarbon. And you have an acid group, hence the name fatty acid. These are only soluble in very nonpolar solvents. Okay, they naturally occur in animals and vegetable oils. The saturated fats, what do you think? Double bonds or single bonds? Yep, they're all single bonds. Unsaturated have double bond. You guys heard of omega 3s and 6s and 7s and 9s and all that? What that omega number implies is the carbon on the chain that has the double bond. That's what that implies. Okay, so generally double bonds in naturally occurring fatty acids are cis. Yes. Naturally occurring fatty acids are cis. Cis molecules are more unstable, okay? So why are they more naturally occurring? Well, we have enzymes that make them, okay? But we've learned that unsaturated fats from natural resources or sources are much better than ones that are made because they turn into trans. And the reason is because cis molecules have a kink in them, and I believe we see a structure. It has a kink in it, which makes these molecules very unstable, and we've got enzymes that can break them down pretty easily. The saturated ones are very, very stable molecules, and we don't really have enzymes that break them down, okay? As the number of double bonds in the fatty acid increases, the melting point decreases, so it becomes more of a liquid, all right? Fats are generally formed from fatty acids, having few double bonds. They are solids at room temperatures. All right, oils are generally formed by fatty acids that have a large number of double bonds. Okay, so let's look at the structures. Here's the structure. Here I have a double bond. Okay, these are usually oils at room temperature. Okay, these are solids at room temperature. Okay, why is that? Well, I hope you can why don't you see if you can come up with something. Why are the saturated solids? Solids means it's very dense. Okay, well, this molecule is able to pack on top of another one of these molecules. So imagine I have this fatty acid, okay? Well, I can pack another one right underneath it very easily, and I can get another one underneath it. And remember, all these are van der Waals forces, all in between these, and I can get another one. I can get tons of these packed on top of each other, packed and packed and packed. So therefore, you form a very dense solid. This, however, has a kink in it. So I can't really pack another one on top of it. So I have another one kind of kinked there, and maybe another one there, another one there, another one there. They're kinked. Notice all of this free space in between all the kinks. Okay? Well, the more free space you have, the less dense, the more likely it's going to be an oil. All right? So vegetable oils, we know vegetable oils are a little bit healthier. Olive oil, all right? Olive oil is really a really good one. Okay? Olive oil, are kinked all over the place, and it's an oil. All right, vegetable oil is another one. Okay, and palm oil and peanut oil, those have other things into it. Coconut oil, let's talk about coconut oil because a lot of people, because it is a solid, if anyone's used coconut oil, but there's a lot of talk now about coconut oil and it being incredibly healthy. Anyone that's heard of like the paleo diet, or the ketogenic diet, really are pushing coconut oil. Coconut oil is a dense solid, but what makes it healthy is that it's what's called a medium chain triglyceride. Okay, what's a medium chain? So you remember we saw back there it said anywhere between 12 to 20 carbons long. Well, a lot of the animal fats, lard and things like that, those are like 18 to 22 carbons long. Coconut oil is about 10 to 12 carbons long. It's what's called a medium chain. It's not as big, it's much smaller. And it's a relatively saturated chain. However, it's been found that not all triglycerides are the same. All right, the size of the chain matters. So what we've learned about polar and nonpolar compounds, all right, if we have less carbons and hydrogens on our chain, all right, it's not as fatty. Okay, it's still a fat, but it doesn't have as many of the van der Waals forces. It's a smaller molecule. And our bodies seem to handle those molecules much better than they do lard and things like that. So it's what's called an MCT. You might, a few of you might be on the paleo or a ketogenic diet, or some of you might be really into nutrition. And MCTs is kind of a big rage now. Incredibly heart healthy. It actually lowers your triglycerides and your cholesterol inside your bodies because our bodies are able to handle them extremely well. They're much smaller fats and oils, even though it is a solid at room temperature. And if you like coconut, man, you should be cooking with coconut oil because there's just a slight taste of coconut oil. There's also, you can actually just buy MCT, a bottle of MCT. Coconut oil is composed of a few acids, but MCT is composed of just one particular acid. I can't remember what it's called. It's not stearic acid, it's a different one. But so that's kind of a real life example of the difference between saturated and unsaturated. Not all saturated fats are bad for you, okay? If it's a medium chain saturated fat, those are incredibly good for you. Okay, I'm gonna stop right there at 3.4, and we'll come back and we'll talk about interesting alkenes in food and medicine.